Hello everyone. Today I'm going to talk about multi-chain storage. Multi-chain storage, also known as MCS, is a smart contract-based cross-chain storage gateway deployed on the Polygon network and integrated with Oracle technology. Data is stored in a decentralized manner using the IPFS protocol, which is incentivized by the Filecoin network. On the Filecoin network, users pay service providers for data storage in their native FIL token. In this way, MCS acts as a middleman, allowing users to pay in other blockchain currencies. MCS is a cutting-edge blockchain storage solution, providing a data cache and persistence layer for decentralized data storage needs. Using MCS, users can upload any data they want to the Filecoin network and IPFS. They can pay for storage with stablecoins like USDC and other mainnet tokens. They can mint NFTs directly viewable on OpenSea. They can access services by connecting a third-party wallet such as MetaMask. They can send or get deals automatically through the built-in AutoBid system. They can merge small files into a single large car file. And we have support for multiple miners for storage. MCS enables users to pay for Filecoin storage with stablecoins and other mainnet tokens while maintaining the data security provided by the Filecoin network. MCS also provides on-chain proof of storage on the chain that the payment was made. Blockchain projects often operate in isolation and hardly communicate with each other. Due to this, users around the world are facing a plethora of networks with their own different algorithms, transaction types, and rules. Without some sort of bridge, users will have a hard time experiencing the full potential of blockchain technology. Since its launch, MCS has been dedicated to closing this gap by allowing users to swap other tokens to pay for data storage in hopes of bringing data storage to the next level of security and decentralization. If we go over to the GitHub, we can view the system design. So after a user uploads their file through the MCS service, they pay USDC or any other MCS supported tokens. The estimated amount for payment is based on the average price of all the Filecoin miners currently on the network, the file size, the number of copies you wish to store, and also the duration of storage. This amount of user-paid tokens are then locked to the payment smart contract. Normally, FIL is used to pay for data storage on the Filecoin network. The user-paid token amount will be swapped to FIL in this step through a decentralized exchange, specifically SushiSwap. After the conversion, storage is provided by paying FIL through MCS's internal wallet. Then any excess locked overpayment will be returned to the user's wallet in the original form of payment. If the DAO scanner detects that the uploaded file is on-chain, it will trigger a signature operation to properly verify that the file has been stored, providing verifiable on-chain proof to the original blockchain for the user. Now I'll go over the user interface for MCS. Heading to the MCS website, we are prompted to connect our MetaMask wallet. And it will take us to show all of our currently uploaded files. We can upload a new file by clicking the Upload File button. Select the file we want to upload. Select your payment plan between low, average, and high. Hit Submit and accept the transaction. And after the payment has been made, we can see the transaction hash and view the transaction on Polygon Scan. After the file is paid, we can mint the file as an NFT. Here we can give the NFT a name, my Galaxy, an optional description. Use the IPFS URL, transaction hash. It will generate the metadata for us, conforming to the OpenSea metadata standards, and mint the NFT to the MCS contract. So we mint, pay for the mints. Again, we can see the transaction hash, and we can also see the link to the NFT on OpenSea. While this one is loading, we can view the previous one for the payment. We see the payment was made successfully. So we can close this one. Clicking on a file will show you the details on the file. It'll show you the IPFS link. It'll show you the amount of locked funds. And then once the Filecoin storage is complete, you'll have more additional information, the signature information, and also the Lotus retrieval command. So if we were to refresh this, you see the mint has been complete, NFT number 105755. So if we go back to my files, click view, and there's our NFT. You can click this external view button to view the IPFS URL. Now I'll talk about the SDK. The MCS SDK is the toolkit for developers, providing a convenient interface for working with the MCS API. Currently, the only supported language is JavaScript, served as the npm package, but Python support is currently under development. This SDK is meant to be more accessible for developers. Using this SDK, developers will have more control and freedom compared to the UI. Installation is quick, it's just npm install. The package is lightweight, and usage is very straightforward following the documentation here. Developers using this SDK can store files to the Filecoin network using supported tokens other than Phil. Files can be minted as viewable NFTs on OpenSea under the MCS NFT collection, all through one function. The metadata will be generated automatically. Scripts using this SDK can be written to upload many files at once, mint multiple NFTs, or even create their own decentralized application on top of MCS. There's many possibilities. Now let's go over the demonstration of the SDK. Following the documentations, get started. There are some prerequisites for using the SDK. You need Node.js, you need a MetaMask wallet, and you need an RPC URL. There's tutorials you can follow in the documentation. You also need USDC and Matic funds. You can get these funds using the Swan faucet following this tutorial also. And to install the package, it's easy. So following the instructions, here I'm in a new project, empty directory. Open the terminal. Let's run npm init to initialize our project, and npm install JS MCS SDK. The next thing we need to do is make a .env file containing our wallet's private key and the Alchemy RPC URL. So I will go ahead and do that now. Okay, now I have my .env file. Let's continue with the documentation. Let's create a new JS file named demo.js. And we need to require the SDK. So we can copy this. Let's make a new thing called demo.js, paste. And then we need to set up the MCS client using our private key MCS URL. And we need a main function to run the functions asynchronously. So the first example in the documentation is to upload a file. So we can just copy and paste the whole thing. And we need to copy and paste the whole thing. So this code will create a simple JSON file containing my wallet address and upload the file to MCS named my wallet address.text. So let's run this using node demo.js. And we get the response from the API, get the unique source file upload ID, the payload CID for the file content, the IPFS URL, the size of the file, and a unique identifier for the content ID. Okay, cool. Now we can get on to paying for the file. Let's copy this. Let's create a new file called pay.js. Paste the code. And we need to fill in some parameters to pay for a file. We need to know which file we're paying for, so let's use the unique content identifier. The amount you want to pay. So right now it's set to 1 USDC. If we leave it blank or even 0, it will auto-estimate for us, similar to how the user interface will do it. And we also need to know the file size for these 6. So let's run this node pay. And it would normally return the whole transaction receipt, but this code will just print out the transaction hash from that. Now that we have the transaction hash, this will also be viewable on the Polygon scan. See, the payment was successful. The next thing we can do, following the documentation, is mint the file as an NFT. To do this, we will need to create an NFT object. So let's create a new script, mint.js. So we need to create the NFT object. We also need to fill in some parameters, such as the source file upload ID, the IPFS URL, and the name of the NFT. Let's call this my second galaxy. So let's call this my demo NFT. We can give it a description. This is my description. And then we save this, run the code, no mint.js. And this will return the Mint API from MCS. So here's a response. We have the same upload ID. We have the transaction hash for this mint. Let's take a look at that later. And we have the token ID. So this is NFT number 105756. And let's take a look at the transaction. You see the mint was successful. And if we take a look on the UI again, so if we refresh this, we see our new file is uploaded, paid for, and minted. So we can view the NFT on OpenSea. And with the same description that we had. In the documentation, there's extra functions to see details in the Filecoin status, but that will be later on when the file is actually stored on the Filecoin network. If you ever need any of this information, you can list files to see all your uploaded files. So let's make another script, list.js. There's lots of parameters you can use. You can sort your files by file name. You can order them ascending, descending. See the payment status, see the mint status, and the number of pages. But we don't need any of that, so let's just leave it all blank. Run the scripts, load list.js. And we see all the information about all of our uploaded files. If we needed to, for example, mint one of the files again. And you can go on the FileSwan GitHub. You can see it's open source. If you have any issues, you can create an issue. And thanks for watching. I hope you enjoyed.